the material subject need not to write the given data everything in the paper mark, because sometimes we can mark the given data in the diagram itself. Need not write here L1 L2 something like that. For example, here check it here how I am writing the given data in the diagram itself. For example, here this is L1, no? Am I correct? L1, this is L2, this is L3. We can mark in the diagram itself. This is diameter D1. This is D2. This is D3. Am I correct? So I written everything in the diagram itself. Suppose you want to mark the load also, just mark the load. So how much load, ma? 40
kilonewton,
N.
sir.
So better to convert into Newton, ma. How do you convert the Newton?
40 into 10 power 5.
5
3.
3, sir.
3. 3 kilo means 10 to the power 3. So 40 into 10 to the power 3. So I marked everything in the diagram itself. So I don't want waste my time in that given data side. Okay, exam time also you can mark like this. And then only one thing we have to write in the given data set, that is Young's modulus. Because Young's modulus we cannot able to write in the diagram. So we can write here 2 into 10 to the power 5 Newton per mm squared. Okay. So what we have to find here, yesterday we discussed that one, find the stresses in the three parts. So I written that one also. Sigma 1, sigma 2, sigma 3. Am I correct? And then what is another thing? Total extension. What is meant by total extension, ma?
Change in length, sir.
Change in length. Good. What is symbol for change in length?
DL.
DL. So what are the two things we have to find? One is sigma, another one is change in length. So now we have to solve the problem. Quickly tell what is the formula for stress?
Load by area.
Load by area. So I can write sigma 1. Sigma 1 is nothing but P1 divided by A1. P already we know that one 40 into 10 to the power 3 load. Area formula, ma.
Pi by 4 d square, sir.
Pi by 4 d square, because we have diameter, we don't have the breadth and depth. So what is the formula? Pi by 4 d square. So what is diameter value, ma? D1 value?
30 sir.
30 no? 30 Okay, I don't want to write. So use the calculator and tell the value. What is the value? Sigma 1. In meantime, I'll write the sigma 2 also. Take a calculator and calculate that value, ma. Quickly calculate and tell all the values. Because you should know how do you operate the calculators. Yeah, correct, ma. The answer is correct. So next one, ma. Next value also simultaneously tell. 30 squared, ma. Better write that. Suppose I'm doing mistake, na, just tell to me. Quickly I'm writing, no. Just calculate the second value also, because subject is easy. Suppose you're doing the work properly.
127.3239, sir.
127.3.
239.
Shall I write 33?
Okay, sir.
Okay. And the next one is P divided by pi by 4. D3 squared. D3 squared. So 40 into 10 to the power 3 divided by pi by 4. What is the value of D3? 32.5. 32.5 squared. What is the value, ma?
48.2173, sir.
48.27. I can write like this, no? 48.27.
Okay, sir.
Okay, ma. Fine. Good. All are correct answer, ma. Everything correct only. Okay, 48 point some values. Next one, ma. How do you find DL, ma? Which formula used to find the DL? Quickly tell.
Strain, sir.
Strain. What is the strain formula, ma?
Change in length divided by original length.
Change in length divided by original. So DL by L. So DL equal to E into L. Am I correct?
Yes, sir.
So do you know the E here? Strain anywhere we found E here? I can reduce the screen also. Check it in the problem. Anywhere E is there?
No, sir.
No, no.
No, sir.
The given data Young's modulus only is there. The requirement stress change in length. We found stresses only. So we don't have the what? Strain. But one more formula is related with the strain. What is the formula, ma?
Young's modulus.
Young's model.
Young's modulus. Because we know only three formulas: stress, strain, Young's modulus. That's all. So stress, Young's modulus equal to stress divided by strain. Strain equal to stress divided by Young's modulus. Okay. So shall I write this formula in the DM? Is it correct? Okay, ma.
Oh, yes, sir. Yes, sir.
So DL formula, what is the DL formula? Sigma stress divided by Young's modulus into length. Am I correct?
Yes, sir.
Okay, ma. So here DL, I can use the red color. So difference will be there. So DL equal to DL1 plus DL2 plus DL3 because we have three components, no? Am I correct? DL3. So DL1 is nothing but sigma 1 L1 E because made up of single material. So E only. This is the first one, DL1. What is DL2? Sigma 2 L2 E. Exam time within one step we can find easily everything. We want to find DL1 first time, DL2 second time. We want to waste our time. I can write everything in the single step. Check it here how I am writing that one. L3. I can do one more steps also here. Easily we can do. E. Okay. So here everywhere E is a common term now. Shall I take E outside? So what is the remaining thing is there? Sigma 1 L1 plus sigma 2 L2. So our work become very easy. Why want to spend the time with the calculator? Is it okay, ma? Yes or no? Okay. 2 into 10 to the power 5. Sigma 1 value, how much you told? 56.59. 56.59. What is L1 value, ma?
180.
190, ma. Any
180.
180, yeah. Quickly tell because I cannot able to move to the screen every time. Quickly tell. Sigma 2 value, ma. How much you tell? 127.33
33.
multiply with L2. L2 how much, ma?
260.
260, ma.
Yes, sir.
Plus, uh, how much you said? 48, I think. So 48.27
48.27.
multiply with L3, how much, ma?
160, sir.
160. That's all. So now tell the total value, dear. DL value, tell the how much, ma?
Sir, 0.2550, sir.
Yeah, correct, ma. He said correct value. Point two
Double
five
five.
five. double 5 mm. Correct, ma.